So we want n to approach infinity. And we want to define our area in terms of this. So we have the area A of the region S that lies under the graph of the continuous function f is the limit of the sum of the areas of the approximating rectangles. So all this definition is saying is that if we think about the continuous function and we think about this region S, and here we are, this is our example from here to here, from here to here, then we can cut this up into an infinite number of tiny, 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 tiny rectangles, like so. That's only probably 30, but you get the idea. Each of these are just very small rectangles. If we have this, what is this? Delta x. The delta x is the width of each of these rectangles. So then that would be very thin right here. And then our f of x would just be the height of the rectangles at each of the n points that we're using. So if we're using a right-hand sum, we would start, we've got this first very tiny width, and we would start at the right-hand endpoint. We would get the y value at that right-hand endpoint. That would give us a height of the rectangle times the base of the rectangle. So here, if we're using a right-hand sum, I don't know, can you see that blue? That would be the right-hand endpoint. That would give us the height. You know, this formula is kind of hard to look at. We've got a way that we can write this to make it a little bit shorter. And the way we write it is the limit as n approaches infinity of the sum from 1 to n of f of x sub I times delta x. So this formula is exactly the same as the previous definition. It just uses what's called sigma notation. This kind of E kind of looking letter is a sigma, and it's telling us to add up a bunch of things. What are we adding up? We're just adding up the base times the heights. So base times height number 1 plus base times height number 2, and so on. The I tells us where to start with the base times height, and the n tells us how many of them or where we want to stop. So we're going to go start with I1, and then I equals 2, and then I equals 3, and so on, up until I equals n. We're going to have to talk about some formulas for this, but this is the idea. This is where we're going to find the area under a curve, between the curve and the x-axis, by adding up an infinite number of rectangles. Now we can't, obviously we can't do this with algebra. What is the sum using algebra? How do you find limits? Well, we need some calculus to be able to do this. And so our next example, we would like to just set up a function for the the area when y equals e to the x from x equals 1 to 2. So what does the function e to the x look like? It goes like that. We want the area from 1 to 2. Let's draw a small rectangle to remind us how this is going. Here's my small rectangle right there. And we need a delta x for this. So what is the delta x? Well, we're taking this whole region from 1 to 2, and we're cutting it up into n parts. So our delta x is 1 over n, 2 minus 1 over n. Then we need to know what is that's the base, right? And now we need to know what the height is. The height is f of x sub I. But in order to write x sub I, what is x sub I? X sub I is just the x value that we are at as we move from left to right, adding up these rectangles. So our formula that we're going to use for x sub I is going to be our start point. So we're going to call our start point A plus delta x times I. So here's what we're doing. We're starting at the start point, 1, and we're adding the base, 1 over n, times I. So I just counts which rectangle we're at. When I equals 1, we're at the first rectangle. When I equals 2, we're at the second rectangle, and so forth. So if I pick I equals 1, where are we? When I equals 1, we are at x1, and we're going to be at 1 plus 1 over n times 1. You can see that this is a right endpoint. Why is that a right endpoint? Because if our first small interval goes from 0 to here, sorry, not 0, from 1, because we're starting at 1, from 1 to 1 plus 1 over n, and we're going to evaluate the function at that point, then what we're talking about is the right-hand endpoint. So our y value, our first y value would be that. Okay, so then what is our f of x sub I? F of x sub I is just going to be f of 1 plus 1 over n times I, and our function was e to the x, so it's going to be e to the 1 plus 1 over n times I. All right, let's put all of this together. The area is equal to the limit, as n approaches infinity, of the sum from 1 to n of the height, e to the 1 plus 1 over n I, times the base. The base was 1 over n. So there we have our setup for the area under the curve e to the x from 1 to 2, written as an infinite sum. Be great if we could actually find that value, but at this point we cannot.